Imagine a world where everyone loves tomato soup, knows how to make tomato soup. Butter, onions, tomatoes, and salt. If you follow this order and with the right ingredients, you'll be able to make the best tomato soup in the world. Across the globe, people make all kinds of tomato soup, but I always follow the same 4 essential ingredients in the same order. Now, we all have our own recipe, so you don't need to worry about not adding in the exact same amount as everyone else because we appreciate all kinds of tomato soup. This is, in fact, the same as your genetic material. The soup that you just made was actually you, and your recipe was your genome, made up of DNA. The ingredients were small units called nucleotides, and there are also 4 of them. They are quite similar, but the genome is just much more longer and compared to the tomato soup recipe, and sometimes the order of the nucleotides might swap. But in most cases, just like adding a bit more salt, it will make a lot of difference. But when it does make a difference, it could be very dangerous or too salty. Let's go back to our soup making. When there is soup that had an issue, for example, doesn't taste like tomato soup, something we could do is to collect their recipe and see what went wrong. We will line them up in order and compare them with the regular ones. There, the soup used onion twice instead of using tomatoes. Now we know what went wrong in the soup making process. And here's the catch. Our genetic material can be lined up in the same way. A missing flavor soup represents someone with a specific phenotype, meaning a trait or disease. The misordered ingredient represents a single nucleotide difference called SMP. And this soup tasting and testing process are called Gwas, or Genome-Wide Association Study. Let's dive deeper. Usually when we conduct Gwas, we will often observe several SNPs in the genome pool. Sometimes these SNPs occur solely due to chance, which does not contribute to the disease we're interested in. But how can we differentiate these SNPs? If you look at a GWAS graph, we'll see that across the genome pools, the higher the dots, the higher the rate that it may contribute to the phenotype or disease. Once the dot has crossed the line called significant threshold, the data will not be considered randomly occurred. Now, why do we do GWAS? As it's important to make a good bowl of tomato soup, being able to identify the cause of certain diseases is also very crucial. With the knowledge that some identifier will lead to a specific disease, protective measures could be taken much early on for vulnerable individuals, such as a newborn baby, to inhibit or even terminate the illness so that both you and them could happily enjoy the tasty tomato soup.